So for those of you that are curious about this, um, I've created this link, DeepSeek. This is pretty like it's happening before our eyes, right? All of this is happening. As you know, ChatGPT has dominated. It was really a competition between Anthropic, ChatGPT, who else? Google, obviously. I don't know why I keep forgetting Google. They're pretty important. So it was really Google, Anthropic, and OpenAI, three major companies, and Meta just seems to be replicating everything. Um, so the four companies basically. And it's all been, basically at one point, Sam Altman, the CEO of OpenAI, said it's futile for you to try to compete with us, right? And, and essentially now some investment company from China or something uh, built a model that should have cost $100 million for $5 million, right? And it's pretty good. And it does mathematical reasoning, which is like astonishing. It's really nice. And ChatGPT already knew how to do that. So I'm not saying where basically they caught up to it. It's not like they surpassed it. In terms of they surpassed it in some ways, but not in like it's not smarter than ChatGPT. ChatGPT probably is still smarter. But this one was trained with less resources. It's more efficient. You see what I'm saying? They literally, whereas we're coding in PyTorch here, they're coding in C and CUDA and finding efficiencies there. You see that? So that's what's happening. It's, probably you know that Python, as I said, and PyTorch are just libraries that are literally running compiled code that's written in C that uses CUDA libraries from NVIDIA to run on GPUs, right? Apparently also they didn't have H100s, but somehow they got some older GPUs and got something out of them. All of this is speculation, is not clear yet. But the reason why I'm saying this is that's the fear that you see right now on Twitter and all over the internet. People are panicking really because OpenAI, if that's true, OpenAI is overvalued by like $1 trillion. You know what I mean? It's huge. Did you see what happened to NVIDIA on the 21st? They lost $1 trillion in market capitalization. 20% of their value went down, which is crazy because they used NVIDIA GPUs to do all of this. So that doesn't even make sense. It's not like they came up with another chip, which would be the dangerous thing. It's NVIDIA. It's all the way, but more efficient. But the companies that are panicking are really like OpenAI, certainly, which that's all they do, right? ChatGPT, and they have a huge valuation. So there's the panic, not in it being smarter. It's just more efficient, more. But there's also a plus side. Now these companies know that this is possible. So think about this. If they had 1 million GPUs and they could train a ChatGPT, now essentially that 1 million GPUs with these efficiencies are equivalent to what? 10 million GPUs? So think how much more intelligent ChatGPT can become. You see that essentially they're smart too, right? So they're like figuring out what they did. Also, NVIDIA, I doubt that NVIDIA didn't know this because they invented, it's their technology. So does that mean that NVIDIA knew that the chips could be more efficient and still weren't, telling you so that they could make more money? That's a possibility if you think about it, right? And so creating scarcity to make more money. But NVIDIA now is obligated to tell everyone how to do that if that's true. It's not clear if that's true or not. So essentially, everyone just triple the size of their clusters, which means more AI, more intelligent, more powerful AI is probably coming. Do you guys see that? So that's in essence the whole chaos and the fear is basically because of that. But anyway, I put together this link of this is me. This is how I collect materials when I'm studying something. And so these are the things that are involved. So obviously C++, how to program GPUs, great CUDA books, to learn the CUDA library. These are all things related to DeepSeek that I've been collecting that I'll talk a little bit about. Unfortunately, though, I don't have much time left. PTX. PTX, so if you've ever heard of assembly language, so PTX is like the equivalent of assembly for GPUs. So the idea is that they also optimize the assembly code. So at a very low level, they're finding efficiencies in memory and things like that to make the models run faster and better. So PTX is a native thing of NVIDIA. It's their assembly language, essentially. Yeah, and then I've been gathering some other notes. So now let's focus on DeepSeek here, the things that are going on. So the two papers, if you really want to learn about this, and I would strongly recommend that you read these papers, they're actually quite accessible, which is one thing I really like. These papers, the first one in particular, such an easy read. It's very nice, extremely well written, like almost perfect, and super easy to grasp. Okay, so this is the one that came out April 20th. Or actually, no, this is the older one. So this must be the one. Yeah, this one. So they created two models essentially, DeepSeek-R and DeepSeek-R1. So DeepSeek-R is like an attempt to make a smaller model, but it turned out that one wasn't as smart as DeepSeek-R1, which is, you know, the bigger one, more powerful. So this whole paper is about how they did that. This is the thing that they say compares to ChatGPT or GPT-4 right now, and that solves math problems with chain of thought, which I think I'm going to have to leave that for another lecture, but it's like amazing. That's beautiful, actually, how that works. And so the paper is called DeepSeek-R1 or DeepSeek-R1, Incentivizing Reasoning Capability in LLMs via Reinforcement Learning. So obviously reinforcement learning yet again. They did several things. The hardware thing they did, they have a really good data set that they describe, which nowhere do they say that they got the traces from ChatGPT. That's not in any of the papers. They said instead they came up with a technique for collecting the data, which I'll have to talk about in the next class, unfortunately, how they did that, but it's in the papers if you want to read it. Essentially, it's almost like they looked for websites that would have problem solving in them. So they took something Common Crawl, which is basically a crawl of the web that's really large. And then in there, they looked for specific websites that had taken a problem and solved it step by step. And then they looked at that and they built a classifier based on that. So some humans looked at those and said, this one's good, this one's bad, trained a model. And then that model went through all these websites again and would say, okay, would rank. These are more like what I just saw. These are not like what I saw. And so that's how they started to collect websites that look more like problem solving versus not. So anyway, and that's kind of the idea. So these are their metrics. They show basically that in all the important metrics, they're very close to ChatGPT. So they attribute their success to that data set, and they also invented essentially or proposed a new type of optimization function. So if you guys remember from 520, you learned the loss functions such as mean squared error or cross entropy, right? Remember we talked most definitely about cross entropy. Reinforcement learning actually started with cross entropy, but it evolved into a few other loss functions. And the current state of the art was something called PPO and DPO. They invented GRPO. So it's a variant of PPO that has some correct characteristics. I don't have much time today. I will definitely cover that as we talk about RL as well. But anyway, so those are the big things. And here it is, actually. And it's actually less scary than it looks. So it's not as bad, honestly, as what it looks. But I'll cover this in the next class. And I want to show you I have only 4 minutes left. So I want to show you something really interesting. This is actually, they show how with these metrics, they trained it, and then they would give it the problem. Then they train it, give it the problem. And as you can see over time, it got better as it was being trained at the task. So they also have that metric. And then essentially, this is kind of the whole thing. They call this the aha moment. Oh, the aha moment. So what is this idea? You can see here, that's an aha moment right there. It's written. So what it does is it uses this thing called chain of thought. It's actually happening at the inference of the model. You train these models through prompt to take a question and not just give the answer, but instead you encourage it to think it through iteratively. So it's like it takes the problem and it says, okay, 2 plus 2 equal what? Okay, it's going to say, well, I have a 2. I have a plus. When I have a number and a plus, I add. So 2 plus 2 is a number. And I think that number is 4. You see that it's breaking the problem down into steps. And so the model was trained to do that. Provide an answer, yes, but don't provide it directly. Do the step-by-step processing until the end. Do you guys see that? And that's the magic. And that's the thing that OpenAI is currently complaining about, because they also apparently, you can get that out of ChatGPT, I suppose. And so they're saying they would give it a problem, ChatGPT would generate the steps and the answer, and then they use that for training as a train set to train their model. So here it's kind of the example, and it's got these nice tags. So it's got problem, think, answer. You see that? And it's all text, by the way. It's all like natural language text that is being given there. So I know this looks like an equation, but it's basically taking what is this problem and it's trying to breaking it down. And because it's essentially they're saying that because humans do this in a sense, we'll say things like, ah, I get it, or aha, or eureka. And they're saying that it even learned that. So you can see that at some point it was talking and it said, wait, that's an aha moment. I can flag here. So it's basically saying like it itself was having this inner monologue that it had arrived at something. You see that? And that's probably as a result of learning from how humans solve problems. So that's what makes it really powerful. And like I said, I'll cover this in more depth because we're almost out of time. But I had prepared some code that I was playing with. And I want to show you that one because I do have kind of the logic in there. So DeepSeek. No, actually, where do I have this? I have this. I guess I forgot the link. But I have this here in the transfer learning folder. So go to the GitHub, transfer learning. And I think I have it. Yeah, DeepSeek paper ideas. So this would be essentially the logic of how the code would work. So you have DeepSeek-R1, and this, if you notice, is just like you learned today. You just use transformers and you just load the model. So in this case, this model is loading probably GPT-2 or something like that. And then you have loading the model, then you have supervised fine tuning, and then you have the actual RL fine tuning over here, which we will discuss a little bit later, next week. But it's got the main functions. So you start the model, you will run a fine tuning, right? And then you will run a reinforcement learning approach where the loss function is this GRPO that they invented, essentially. But what I want to show you that's kind of really, and this is the definition of that equation, and then you just generate text. The rewards also, here's another thing. Even though I've been telling you all day in the class, take a BERT and build a reward model, in fact, they say that they didn't do that. They created the reward functions heuristically, like rules-based. And here's an example of it that I'll talk a little bit about later. This is pretty simple. If it's think, give a 0.3. If it's, something else, give another value. But I'll end with this. This is what the training set looks like. Do you see that? So think about it. So before, what were we doing? We were giving something the paragraph and the summarization and nothing else. And we would tell the model, learn how to do this. Somebody invented chain of thought, which is another paper, not that old. And chain of thought said, no, no, no. Use language, but like this. Take the question as an input, and then in the output, break it down into a list of things. So if you notice, you got think, 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 answer, right? And you give it examples so that, and then now the model learns to produce that. And that's how they're trying to give it reason, because you can see that, you give it enough problems about cars and airplanes, then maybe later you ask it about motorcycles, and it's probably able to generalize to that because they're vehicles, right? You can see that. So it learns to reason about motorcycles, even though it never saw that because it reasoned about the other things. So that's what they were doing with math. They were teaching it, lots of math problems. I heard it's 800,000 of these. And they're pretty long. This is just very short. So they would take like a tough problem, several think steps, and arrive at an answer. So you can see here this example. What is 2 plus 2? Think. Step 1. Start with first number, 2. You see there's a little bit of prompting going on. Think. Step 2. Add the second number, 2. Think. Step 3. The result of the addition is 4. And then finally it gives you the answer. And these also can be variable length. So it can, for some problems, you can think longer, shorter. Does that make sense, guys? So this is essentially the data that, like, the holy grail. They say that they got this from a common crawl. And the description of how they did it is in one of those 2 papers. So I encourage you to check it. Right. I will come back to this next time we meet, but we're also going to continue with our goal. Remember, right, and this is actually very timely because we were going to do reinforcement learning through human feedbacks, just obviously not as sophisticated as what they did. But all right, so any questions? You seem to have a question? Oh, okay. Any questions, guys? All right, so we're over a couple of minutes, but we'll stop here for today. Look for a homework assignment before Friday, okay? I'll provide all the information, and if I have to describe it in a video or something like that, I will.